Welcome to the Modern Application Development 2 screencast. In this screencast, we'll see how to measure and improve performance. For this, you will need a Linux environment. You will also need redis. So please install and run redis. Now, performance measurement and improvement is a vast subject. There are many areas of application in which a bottleneck might appear, but we'll see some of the common scenarios, and we'll also see how to mitigate them or improve the performance in such scenarios. Now, before we start, let's look at the application that we have. We have an application with various files inside the application folder, and our main app is in the main. Now, before we continue, I want to organize it a little bit better into different modules so that going through it becomes easier and managing it becomes easier. Now you can skip it forward if you don't want to watch it, but it's quicker. I'll just go ahead and do it in front of you. Within the application folder, I'm going to create 4 new folders called controller, okay, and then a folder called data, a folder called jobs, and a folder called utils. Okay, now I'm going to move API, controller, and webhooks into a controller, right, and workers, tasks into jobs folder, and database and models into data folder, right, and validation into utils folder. Now since they're all modules or packages, I need to add a underscore init file. So I'm going to just do that. I'll copy this, just paste here, paste here, paste here, then paste here. Okay, kind of almost done. So we just need to change the package path. This is just to show that all the controllers, whether it's API or generic web controllers or webhook controllers, are all in the controller folder or module, and all the database related things are in data, all the jobs related things are in the jobs, and all other utils, if you have any more, you can put in the utils, right? Makes it a little more cleaner. That's all. I'll just quickly change the imports so that they work. This application dot it comes from utils, right, and this comes from data, this comes from data as well. Anything else? Nothing else here. And here main.app, here this comes from data, and application dot jobs import tasks. Okay, webhooks, same here, application dot jobs, here data. Okay, rest seems okay. Can do similarly refactoring in other things too, just to make it clean and fast. Cleaner rather than faster, because I think if it's cleaner it becomes easier to debug and improve it upon in the future. Here it's jobs. Okay, it seems to be okay. Util seems to be okay. Now we just have one more file left, which is the main.py. This is correct, this is correct. This will be data. Okay, and here are some of the imports. Okay, that's it. I think we've reorganized. It's pretty much clean, right? So let's start it. I've already set up the environment. You can see here. Consider.env. If you want, you can set up it again. So I'll just run it just to check whether all the changes are okay. Okay, seems to be okay. Let's just open a page and see if it loads. Okay, so the restructuring is fine. Okay, now we want to see how we can improve this application from 2 points of view. One is from the front end point of view and another one is the backend point of view. Backend, there are 2 parts, mostly the processing that we are going to do and the queries that we are going to run. For example, let's take a controller. Okay, here is a controller. There are 3 things that are happening here. One, we are getting when the user accesses slash, it's going to come to article and it's going to do some processing. If there are loops or anything like that, it's going to do a query, then it's going to render the template and then return to the user. Now if the articles are not going to change very often, we don't need to run this for every user all the time, right? Or for example, we don't need to run at least this. If you want to change some rendering, for example, if the rendering has username that you don't want to do, then we can want to render this, but we don't want to repeat this. So you can actually, reduce the process at various levels. So you first will start with measuring and then we'll see how to reduce it. Let's start measuring. For measuring, we are going to use a simplest function called puff counter ns. It's a built-in Python function that we can use. It starts a timer and then you can start or stop the timer whenever you want and measure the difference. Let's start doing that. Okay, now I'm just going to add here. I'm just going to use the nanosecond one and not the second one. So only this is enough. So let's say we want to improve this. Let's assume that this is the one which is taking a lot of time. We want to improve this. So let's add a start pointer, right? And then we will add a stop pointer. Right, stop. Okay, and then we'll print it. Print time taken stop minus start. It's the end minus start. Let's see how much time it takes. Here we don't have many articles, so it might take a quite less time, but assume if you are running a media organization where there are tens of thousands of articles, then this query would be taking a lot of time because it's trying to query all over the whole table. Even if you have some constraint, it's going to run over the table and then reduce and do all of those. So generally listing is one of the areas that we concentrate when you are improving the performance. So we'll see how much time it takes. Let's stop this, start again. Okay, and let's refresh this. Okay, I have not closed the page, so here it is. So it's taking some nanoseconds, right? And if I refresh, it's roughly changing, but it's taking somewhat similar time. It changes sometimes based on whether the code is already compiled, it's in the memory, all of that based on that. but it's taking what we call significant amount of time, because we know that it's entering here, running this query and all of this. What if the articles don't change often? Let's say all our editors upload the article in the morning and we don't change articles during the day, and only in the evening they'll upload again. So we could literally cache this for a whole day, without querying the database every time the user accesses, right? So if in case if this whole thing came from memory, it would have been really fast instead of hitting a database. Now here we are using SQLite, so it's on the same machine, and it's relatively fast because I'm using an SSD, and also I have data in that very less data compared to any media organization. But assume a case where you are hitting a Postgres database on a different machine, and there is a network call, network query, getting the data and doing the stuff. Then actually optimizing this becomes very important. Let's see how to optimize this. If you want to optimize this, basically I don't want to get this every time. I want to get it only when it's required, or cache it for a time that I don't want to query database all the time. Okay, to cache this we are going to use a library called flask caching. It's one of the recommended ones by the Flask project itself. You can go check the project. Can install it by pip installing Flask caching. I've already added to requirements.txt here, and I've already installed it, so I don't need to do any further installation. Go ahead and install on your local machine. Once you install, we need to do some setup. Flask caching supports multiple types of caching. You can make it null, which means no caching, and there is simple caching, redis caching, and various kinds of caching. We could use local file system caching, in the sense you read from the database, write it to local file, and read it from there and display it to the user every time you want to. Or you could use redis, because since redis is a fast in-memory key value database, it could be much faster than actually calling the database. Similarly, you can use memcached. In this case, we are going to use redis cache, because we already have the redis running, and we are going to use the same redis for many things. It's a multi-purpose tool. So we're going to set up cache type here, right? And since we're going to use redis, we're going to set it up redis cache in the config, right? And then since we are going to use redis, we're going to set up the host, and we have to set up the port, right? Host will be localhost, because I'm running on the same machine. Most of the time, if you want to use something as a cache, you would probably want to run it on the same machine to reduce the network call. I'm going to copy paste the same into the local development and staging, right? So now this is we have added the configuration, but we have to enable caching for our application, and that can be done like any other app initialization we do. We'll also do cache initialization. So import cache, then similar to how we do other app initialization, we'll also do cache. So it's just we'll do it at the end, then just push the context again and return cache, because we're going to use it and refer it in multiple places. Okay, and I'm going to set up the cache as null in the beginning, or none, and then initialize it, and this will use all the things from the config, and then create it. Okay, this seems to be done. Now we want to do it here, right? Now usually we actually try to keep the access functions or methods in a separate module or in a separate file, and so that it can be um, uh, reused across different calls. For example, I had articles if I had a function called get articles that can be used here, that can be used in an API, that can be used in a webhooks, all of that will use the same function and it can be reused. And it's very useful because then you can apply your caching, your authorization, or any other things that you want to do at one place, and it applies regardless from where it is accessed. So what we'll do is we'll create a file called data access. .py, and I'll add some functions to it so that it can be used by our controllers, right? First thing, I'll add article and article likes. Okay, and then I'll add a function called get articles, and it's going to do one simple thing. It's going to return the articles. Okay, similarly I'll add another function, get articles by username, that also we use in one of our controllers, and I return the articles filtered by the username, right? Now let's take this get all articles and use it in the controller. Instead of this, we can just get our articles. Before that, we'll just do from data put data access. Is the spelling correct? ACC, yes, is correct. Okay, now we'll call this there. All right. Similarly, here, instead of this, we could use get articles by username and pass the username, right? So okay, now this is all done. Okay, so your start is there, end is there, data access is there. Now we just want to cache this. Instead of that can be done very easily here, right? So basically we want to cache the output of this. Whenever this gets called, we want the cached output to be returned, and that can be done very easily by using a cache. Okay, so this says cache it for at least 50 microseconds or milliseconds, and the cache prefix is get all articles, right? So now one of the things that you might have to do is to change your models, because I think since it's in time, the lazy dynamic won't work for the article authors getting. So you might have to change it to get it using subquery so that it gets everything and caches it. So that can be done just by changing lazy is equal to subquery. This. Okay. Okay. So now we are ready. Let's check whether this works. Okay. Controllers. Okay. Let's check if this works. Start this. Okay. So it took that much, that much, that much, that much. So let's check the difference. Right, this is the first term axis, this is the subsequent axes, right? So you can see how small they are compared to the first term axis, right? At least 10 to more than 10, 100 times smaller, right? It's a factor of that. So so it's significantly faster. Now if you had a much bigger data or much bigger database, this could have been, this first number would have been much bigger, right? This first number would have been much bigger. This would be somewhat similar because it's still reading from memory. What we are using here is the flask cachings cached here, this one, and key prefixes all comments, and usually you keep it unique so that if you don't want two functions to return the same thing if you have the same prefix or if they have the same name. So ideally you would want the key prefix to be separate so that the keys are unique and are cached properly. The other one to remember is the timeout, right? And if it automatically times out. We could also define a standard timeout in our config. We are not defined here, but we can define a default timeout. We can define a default timeout. There will be a default timeout. Yeah, cache default timeout. We could use this. Could keep it to 300 milliseconds or something, and then you can override based on the requirement of that specific function. You could also do this for this, but here is a small change. This has to have for username. So this doesn't have any input, so the output always remains the same regardless of what is the what is the username or who is the user, or regardless of whether he is accessing from the first page, last page, whatever page, right? Unless you have a pagination as part of this, but we don't have it. But in this, it differs because this is articles by username. This is usually getting called when we access this link here, and this could be different users, right? Hence we should cache it differently for different users. Otherwise, sometimes if you don't do it properly for all users, it will show the same content, which is wrong. That's why we are going to use a different caching way to do it. It's called memorize. Right? So let's go back to the documentation and see what memorize means here. So in memorization, the function arguments are also included into the cache key. So along with the name, it's the function parameters, like whatever the actual value of username is also used as a key, so that it indirectly it is like, for example, the key is like roughly it would be like this, right? Roughly the key would be like this, and hence that would be unique for each of the query, right? And this we don't need to do, the memorize automatically handles it, right? And 50 is the timeout period. So let's try that also. Let's go back and add the similar timeouts for that, timers for the same. Okay. I'm going to remove login required for now. Okay, now let's say we click on this. Username is not defined. Where is this? Okay, this is user underscore name. Okay, okay, let's stop this. I think it's a similar. So the way caching does is it actually takes the output and pickles it and stores in the redis. So sometimes if the object cannot be pickled and put in, then there will be an issue. So let's see what is the issue here. Okay, there was a small bug here. That is because in data access we are actually returning the session and not the actual response of the query. So I'm just going to do dot all, so it gets all the objects from the database, runs the queries and gets all, and then actually returns it, so that that result can be cached and not the reference, right? So this will be actually the query, right? Now let's see if this works. Let's restart the server, right? And okay, there it works, and you can actually see it in the Redis too. By default, Redis flask cache uses the database 0. If you don't give any, you can give the specific one. You can refresh this to see, for example, this is the current one, and it's been cached with a TTL, I think, which is reducing. If you keep reloading it, it will keep changing, reducing, right? Once it expires, it actually queries again from the database and gets it. Let's go back to the home page and see. You can refresh this. You can see that, flask cache under get all articles is there, and it's getting expired. The previous one got expired, and then this one is still valid. It's for another 44 seconds, and even that is gone now. So that's how you actually get the caching working on the backend in the database part. Now you could also say that this whole thing doesn't change that often. If the database values are not changing, and if it's same for logged in users, logged out users, and all of it, and you don't want to change any of this part, you want to respond with the same values regardless, then you can cache it at the whole controller level, right? You can cache it at this level. This will be really useful in an API where you want the response is going to be same, and you can cache the whole response so that you will avoid database calling, marshalling, demarshalling, all of that effort, and just respond quickly. It can work with authentication. uh, you know it doesn't mean that just for an example I removed authentication for one of the thing because I didn't want to log in. Otherwise the caching also works with authentication. Now let's see here. Let's add a caching at the whole articles level, right? Let's check whether how to add it. So it would be just that, right? So let's see if it caches for, let's say this is cached for 50, and let's say this is cached for much smaller time, right? It could be 20. Okay, I need to import it in the controllers. Okay, start this. Okay, now let me just go back to the browser, and if I do this and this, you can see that the first time you see that time taken has been printed, the rest of the times no time taken has been printed. That's because it doesn't even enter this. It responds directly from here. We can even see that the cache, you can see, let's refresh this. We'll enable auto refresh as well. See, you can see the whole view has been cached. It's a slash view, right? That's why it's showing slash here. The whole view, whole HTML has been cached, right? So that the whole time that takes to run this, render this, all of that gets saved because we're just loading it from the cache. Now you can also time out the caches when you want, if you want to immediately clear for some reason. For example, you have a long-term cache, you get reading the things, but when you post something you want to expire the cache. That also you can do by expiring the cache or deleting the cache. Basically you could, it's same function as deleting this from here, and that would expire the cache, right? Or you could have a function called expire or delete. Let's just check here. Yeah, right, you can delete the memorized cache, right? Or you can delete by key as well. Both of them will work. Now you can also use caching within Jinja2 templates if you want to cache, just like how in controller we cached only small part of it, right? If this was not used, we are caching only this part, right? Similarly, within the whole article.html, if you want to cache only small parts of it, you could cache that as well. You can see that in the tutorial. I'm not going to show how to do that. You can see it in the tutorial how to do it. Now this is one step and the most often used step to improve the performance. You also saw that I'm printing the queries here when I run, and you could use explain on the database to get explanation on the query, how it runs, and then you can add indexes and stuff. I'm not going to take you through that because I think you would have learned that as part of your DBMS. Similarly, you could also do memory or line profiling or memory profiling at the Python level to check how much memory it is getting used. Are there any objects that's not been garbage collected, etc., to improve the performance of the Python program. This is similar to any other Python program. It doesn't have to be just for Flask. If you can do this with your regular Python program, you can do in a similar way for Flask app too. There I'm going to just stop the backend optimization, and I'm going to show how to measure the front-end performance using something called Lighthouse. Now Lighthouse is a project, maybe I'm not okay. Lighthouse is an open source project by Google for measuring performance. It's also been integrated into the Chrome. So when you right click and click on inspect, you can go to the Lighthouse and it will show a Chrome, and then you can choose the categories. I will probably choose, you can do progressive web app checks, performance checks, best practices, accessibility and SEO checks. I'm just going to check, because this is not a PWA, I'm going to just check these three, right? Click on this and generate report. It will take a couple of minutes to run. And gives you a report. Also some instructions on how to improve any performance related issue or the best practice related issue. Okay, it's done. So here you can see the performance is 22 and best practices is 77. It also shows, if it is in red, it's actually quite bad. Yellow is okay, and green is great. It shows some of the values, how much each one took and what it means. Like the image size is big. You could have reduced the image size to improve the loading time, for example. That's one of the inputs that you can use. Formats of the images, for example, I think most of them are using PNG here. You could use other formats like WebP, especially when you're delivering to Chrome, to improve the speed. Many other, I think you can go through them and see to work on some of them. You don't need to work on all of them. You can work on some of the them which actually brings a larger change, and you can improve this. For example, in our IIT degree site, go to the lighthouse, and I'm just going to say the same thing and click on generate report. Okay, you can see that the performance is 56 and the best practices is 77. Sometimes it also depends on the speed of the internet. I mean, if your speed is or the browser is slow, it could reduce. You can run it at multiple times to take an average of how the performance is. It does shows like you could, I'm using third party, for example YouTube embeds, and I could reduce it to make it faster, things like that. Some of them you can't do anything, but some of the other things you can work on them to improve. The tips are actually good. You should go through them and improve. If you are interested in accessibility, you should run the accessibility test as well. The Lighthouse site itself is actually quite useful. You can check the scoring guide and tips how to improve the scoring, right? And that's very useful. The other thing I would want you to look at is whether the gzip caching is enabled. For any site, for most of the requests, you can look at the network. For example, if you look at the network, it shows multiple response headers and also shows whether the gzip is enabled or disabled. Gzip is a way of compressing the content in text plain or text HTML compressed on the server side and sent gzipped basically and sent to the server client, and the client like browser like Chrome can decrypt it and show it to the user. That way the bandwidth that is used on the transport is very less, and it will be much faster. So it can you can, when you send a request, you can say that, or your browser actually says that it can accept gzip, and most of the time servers will respond with the gzipped content. This may not work with our development server, but it will surely work with the proxy like Nginx that we had shown in the last deployment process, right? And then you can enable the gzip. Those are few things that you can do to improve the performance. And again, this is like much vast subject, and we can keep looking at more and more ways to improve the performance. The first thing is to identify where the bottleneck is, and I would like you to add performance counters everywhere that is possible, and use cached content as much as possible, because it's easy to implement and easy to use, and two, it brings a lot of value in the sense that it makes your application really fast without much effort. Thank you for watching. That's all.